This is Algebra 1, Chapter 4, Section 3, Quick Graphs Using Intercepts. Today, we are going to find the intercepts of a graph of a linear equation, and then we are going to use those intercepts to make a quick graph of the linear equation. The vocabulary for today is x-intercept and y-intercept. If you remember, the x-intercept is where the graph of the line crosses the x-axis on a coordinate plane. So in this case, this here is the x-axis. The slope of our line, or the graph of our line, is crossing the x-axis at this point right here. That is the x-intercept. The y-intercept can be found on the y-axis. It is where the graph of the line crosses the y-axis. For the graph of this line, it is crossing the y-axis at that point. Let's look at the x-intercept again. We don't know the value of this point, but if we wanted to represent it using a coordinate, we would represent it like this: x, 0. Because we have moved along the x-axis, so the x would have a value. We just don't know what it is, which is why I used a variable. But we definitely did not go anywhere on the y-axis. So in the x-intercept, the value of y is always 0. For the y-intercept axis, we went up and down. So we did not go anywhere on the x-axis, which means that our value of x in this coordinate would be 0. And since we don't know the value of y, I am going to represent it using the variable y. So you would plug in your value of the intercept right there for the variable y. You can also find the x and y intercepts using algebra. In example 1, we are asked to find the x and the y-intercept of the graph of this equation, negative 3x plus 4y equals 12. Let's start with the x-intercept. To find the x-intercept of this equation, we need to first make y equal 0. Remember, when we're finding the x-intercept, y is always going to equal 0 because we are only looking on the x-axis where y always equals 0. So when we use algebra to find the x-intercept, we're going to let y equal 0. So we're going to take our original equation, negative 3x plus 4y equals 12, and we are going to substitute 0 for the variable y. Now we can simplify our equation. 4 times 0 is 0, so we are just left with negative 3x. Now to solve this one-step equation, we'll divide by negative 3 on both sides, which means we are left with x equals negative 4. The x-intercept, where the line crosses the x-axis, is going to be negative 4. And that means this coordinate is negative 4, 0. Now to find the y-intercept, we're going to do the opposite. We're going to let x equal 0. Because as we mentioned earlier, the y-intercept is on the y-axis. That means x will always equal 0 in the y-intercept because there is no x value. So if we substitute the 0 for the variable x, negative 3 times 0 equals 0, so we are left with 4y equals 12. Now we would solve our one-step equation by dividing by 4 on both sides, which gives us y equals 3. The y-intercept is 3, so that means the graph of our line crosses the y-axis at the coordinate 0, 3. To prove that these are the intercepts of this equation, we're going to go over here and graph this equation. I know we haven't gone over this yet, graphing using slope-intercept form, but I'm just going to go over it quickly. So first I want to put this equation in slope-intercept form. So I'm going to add 3x to both sides. So I'm left with 4y equals 3x plus 12. Then, to get the y alone, I'm going to divide by 4. So I'm left with y equals 3 over 4x plus 3. Now this is my equation in slope-intercept form. So I'm going to graph this for you so I can show you where the intercepts of this graph actually are. First, we're going to start with the y-intercept, which is 3. So I'm going to graph positive 3 on the y-axis. Now right there, just knowing that B is the y-intercept, I already know that my y-intercept is 0, 3. Now I'm going to start with my rise, which is the numerator, and I'm going to go up 3 and to the right 1, 2, 3, 4. So the next point on my graph is right there. I want to make it more even, so now I'm going to make them both negative so I can do the opposite direction. Down 3, to the left 4. Oh, and there we go. Perfect. I hit the x-axis exactly where I wanted to. So now I can draw the graph of this line, and I can identify now that this here is the x-intercept, which is negative 4, 0. And this coordinate here, the coordinate that's on the y-axis, is our y-intercept, which is 0, 3. So these two coordinates, our x-intercept and our y-intercept, are what we just found over here using math. So we are correct. Now we're going to go over how we can use our intercepts to graph the equation instead of graphing in slope-intercept form. Like this thought bubble says, only 2 points are needed to determine a line. So when you find your x-intercept and your y-intercept, once you plot those 2 points, you have the graph of your whole line. So we are going to use this equation, 3x plus 2.5y equals 7.5. First, let's find the x-intercept. We substitute 0 for the variable y. 2.5 times 0 is 0, so we are left with 3x. 3x equals 7.5. Solve your one-step equation by dividing by 3 on both sides. So x equals 2.5. So the coordinate for our x-intercept is 2.50. To find the y-intercept, we're going to substitute 0 for the x-coordinate. 3 times 0 is 0, so we're left with 2.5. Y equals 7.5. Solve your one-step equation, divide by 2.5 on both sides, so y equals 3. The coordinate to represent your y-intercept would be 0, 3. So we now are going to plot the points 2.50 and 0, 3. And then we're just going to draw a nice line through those 2 points. Let's start with the x-intercept. We're going to graph the x-intercept on the x-axis, 2.50, 1, 2.5. We're going to plot that point right there. And then our y-intercept, which is 0, 3. So we're going to graph that on the y-axis, 0, 1, 2, 3. So our y-intercept is right there. Now we can draw our line. Be sure that these lines are accurate. Nice straight line, preferably on graph paper. Now, I want you to solve for the x-intercept and the y-intercept of this equation, negative 4x plus 5y equals 20. Then you can graph this equation in your notebook to be prepared for class tomorrow.